In this lecture, we're going to play with the base class access specifiers we learned about in the last lecture. In other words, we're going to play with public, protected, and private inheritance in Visual Studio Code. So let's review a little bit what we talked about in the last lecture. We said that we can have public inheritance, and the syntax to do that is what you see here. And the moment you do this, what was public in the base class is going to be public in the derived class. What was protected is going to stay protected. What was private is going to become private in the derived class. In other words, public inheritance is really not going to change the accessibility of the member variables we have in the base class. We're going to inherit the data as it was with the same access level we had in the base class. This is a defining feature of public inheritance in C++. We can also do protected inheritance, and what this is going to do is to make protected the highest access level we can have in the derived class. So anything that was public in the base class is going to become protected. Anything that was protected is going to stay protected because that's the highest level we can do now. And anything that was private in the base class is going to be private in the derived class. We say private in the sense that it is going to be private to the base class. So you can't really use M3 from the player class in this case. If you try to do that, you're going to get a compiler error. Okay, we can also do private inheritance, and the syntax to do that is what you see here. And now private is going to be the highest level we can do in the player class in terms of the members that we got from the base class. So anything that was public is going to become private. Anything that was protected is going to become private. Anything that was private to the base class is going to stay private to the base class. This is what we mean here. But now M1 and M2 just became public to the player class. If anybody else tries to derive or inherit from a player, these things are not going to be accessible. And this is in some way the player class being selfish. It is saying, I am going to get everything I can from my parent class or my base class, but I am going to make it all mine. Nobody else can take this. And this is the kind of setup we can achieve with private inheritance. Okay, so now that we have this in mind, we're going to play with this in Visual Studio Code. We're going to set up a bunch of classes. We're going to set up a person class we're going to be inheriting from. We are going to set up a nurse class, which is going to do protected inheritance. And we're going to set up an engineer class, which is going to do private inheritance. And we're going to really play with this and see how this plays out in real C++ code. So let's do this. Here we are in our working folder. The current project is base access specifier, a demo. We're going to do a demo on this, but before we do that, we're going to grab our template files and put them in place. And we are going to open this little guy in Visual Studio Code by dragging and dropping here. This is going to give us a good starting point. We're going to have our main CPP file. We're going to clean it up, and we're going to set up our base class, which is going to be the person class. So let's put this in from scratch. We're going to add our files. We're going to say person h, and we're going to say person.cpp. We are going to hop over in our header file and put in our code. Nothing special so far. We have an include guard. We have our person class. It has a bunch of member variables. We have the full name, which is public. We have the age, which is protected. And we have the address, which is private to this class here. This is going to be our starting point. We also have a bunch of constructors. We have a default one. We also have another one, which is going to take all the data we can use to construct a person object. And here we are passing a const string by reference. I think we can fix this and pass a string view. This is going to be better. Let's say string view. And we're going to change the first parameter here to be an std string view by value. This is going to be much better. Okay, we have our class. We can hop over in the CPP file and put in our implementation. We are going to change the constructor a little bit and make sure we are taking an std string view by value. And if you want to type all this code, you can get it from the resource section of this lecture. I am going to attach all the source code, and you can download and use this however you want to really make your learning experience as pleasant as possible. So we have our constructor here. It is going to forward the data into our member variables. The full name is going to go into our full name member variable. We're going to grab the age and the address, and we're going to store all this information. We also have an output stream operator, which is going to be printing all this information here. It is going to go through the getters because we have a person object passed as a parameter here, and this is going to work. We can go in the main CPP file and include our person class and create an object of it. We can do something like person1, and we can pass the data that our constructor expects. We can pass in the full name, the age, and the address. So let's do that. We're going to say the full name, Daniel Gray, why not? And the age is going to be 27. We can put in whatever we want. And we're going to put in the address. We're going to say Blue Sky Street. We can say 233, for example, and say the number of the house to be 56. Why not? This is a possible address for a person. So we can say person1, or we can use stdc out to print this out because we have an output stream operator for our person class. We can do this. We're going to say person1, and we're going to put him out. And if we build and run this program, we're going to see that this is going to work, hopefully. And we have a problem because we don't have a semicolon at the end of line 6 here. Let's fix that. We're going to run this task to build with GCC. The build is going to be good. We can bring up a PowerShell window, and we're going to use this to run our program. If we say rooster, we're going to see that we have the person printed down. The full name is Daniel Gray. The age is 27. The address is Blue Sky Street 233. And the number of the house is 56. So this is a possible implementation for the person class. But we are really not interested in setting up a person class and doing things with it. We are interested in inheriting from the person class and learn about different kinds of base class access specifiers we can do. So we're going to set up a player class, which is going to inherit publicly from the person class. Let's do that. We're going to put in our player. We're going to put in the header file. Let's say player, not person. And we're going to say player.h. We're going to put in a CPP file. We are going to hop over in the header of player and put in our class. Let's close the left sidebar here so that you can really see everything. We have an include guard in. We have the class player declared. It is going to do public inheritance from person. And what this is going to do is that anything that is public in person is going to stay public in player. Anything that is protected is going to stay protected in player. And anything that is private is going to stay private. So we want to be able to access private data from a person object. For example, we can't access the address member variable here because it is private, but we can use the full name and the age from the derived class. Let's make sure we have a CPP file n before we try things out. So let's hop over to the CPP file and put in a possible implementation. We are going to include the person and player because we're going to be using these. And we are going to set up a constructor which is not going to do anything for a player. We also have our output stream operator which is going to print the data. It is going to be using the getters we have in the base class, and we have access to them because we are doing public inheritance. So they are going to be public, and we can call them from the outside like we are doing here. Notice that this is an outside player object, and we are calling our public members on it, and this is going to work. We also have a destructor n, which is really not going to do anything, but we're going to keep it in here because it's not going to hurt. So now what we want to try out is to see if we can access things from the base class. The first thing we have in the base class is the full name, and I think we can actually copy these things, or we can just use them, m full name, m age, and m address. We're going to try and use them in the derived class. So let's try and say m full name and change the full name, for example, to be Daniel Gray or Jon Snow. And we're going to change the age to be 55. Why not? And we're going to try and access the address. Let's see what we called our address member variable. It is m address. We can grab that and use that in our class. If we try to access that, we're going to get a compiler error because that's going to be private to the base class. You notice that if we even try to put some junk data, we're going to have a squiggly line because this is not accessible here. And Visual Studio Code is going to say that this is not accessible because it is private to the base class. So we can access M full name because it was inherited as public. So this is going to be okay. We can use age because it was inherited as protected. We can use it in a derived class, but we can't use the address because it was inherited as private and it is private to the base class. So this is not going to work. Even if we try to compile our code, we're going to get a compiler error. Let's try to do that so that you can really see for yourself. Okay, so we have a compiler error and this was declared in the base class as private. This is what the compiler error is saying. So we shouldn't really be doing this. The derived class has no business modifying a private member of the base class. This is the message here. So we're going to comment this out and say that this is going to give you a compiler error. But we are also going to create a player object and try to access these guys and see how accesses from the outside. So we're going to go in the main CPP file and we're going to include player.h and we're going to create a player object. We can put in a separator and say a bunch of dashes here. This is going to do, I think this is going to work. And we're going to create a player object. We can say player and not put any parentheses here. This is going to call the default constructor that we have in our player class. And we can try to use this. But before we do, let's try and build and see that this is going to build just fine. We're going to build with GCC. Let's do that. We're going to see that the build is good. We can try and access stuff from this player object. We can say player and say M full name. You see that this is accessible. We can actually change this to Samuel Jackson. We can do that. But if we try and say player MH, we're going to see that this is not accessible here because this was inherited as protected. If we go back to person, we're going to see that the age is protected. So it will be accessible in derived classes just like we did in our play method of the player class. But we can't access the age from the outside of a player object because that's not going to be accessible from the outside. This is a defining feature of the protected access level. So this is not going to work. Even if we try to build, we're going to get a compiler error along the lines of this is not accessible in this context and it was declared in the base class, so we can't really access it from the outside. This is the compiler error here. So we're going to comment this out and say that this is going to give you a compiler error. Okay, so I hope you know that you can't even have a chance accessing a private member of a base class from a derived object in the main function like we do here. So if we try and do player and say M address, this is not going to work. Okay, so if we try to change this, for example, to some junk data, this is not going to work. We're going to get a compiler error because this was declared private in the base class. And it is private to the base class. You can't really access it from the outside. You can't even access it from a derived class, so let alone access this on the outside in the main function. So this is not going to work. It is going to give you a compiler error, but we're going to build and show you the compiler error because we are learning here. So we're going to get a compiler error that says M address is private within the context where we are trying to use it. So we can't really use it from the outside here. Again, this is going to give us a compiler error. Let's say that here. And this is really what I wanted you to learn about public inheritance. Anything that is public in the base class is going to be public in the derived class. Anything that is protected is going to stay protected. And what that means, it will be usable in the derived class, but you can't use that from the outside. And anything that is private in the base class is going to stay private. So you can't use that from the derived class, and you can't even use that from the outside like we are doing in the main function here. This is not going to work. Okay, so now that we have this in place, we're going to set up another class that is going to do protected inheritance, and that's going to be our nurse class. So we're going to put this in. Let's put in a nurse header file. This is going to be nurse.h. We're also going to put in nurse.cpp. Okay, so we're going to head over in the header file and put in the code for our nurse class. We're going to say class nurse and say protected to mean that we want to do protected inheritance. And what this is going to do, anything that is public in the base class is going to be protected in the derived class, which is our nurse class. Anything that is protected is going to stay protected. Anything that is private is going to stay private to the base class. This is what we mean here. Okay, now that we have this in, we can put in the implementation for our nurse class. And we're going to have a constructor and we're going to have our output stream operator and we're going to have a destructor, which is really not going to do anything because we don't have any dynamic memory allocation in our class. We are going to try and build this code to see that it is going to work. We have a squiggly line in the main CPP file, but it was because of the line 15 here and it has been commented out. Let's see if we can build this program. Okay, you see that the build is going to be good and we are able to call, thanks from our output stream operator, you see we have a nurse operand. We are able to call this get full name and get age member function because they are now protected in the nurse class, but we are able to call them from the outside because this operator is a friend of our nurse class here. I want you to say this. Some of you are going to ask, aren't we using an object and calling a method using the dot operator? This qualifies as calling things from the outside. And yes, that's true. But this method is really like a member function in that it has access to private and protected data from our nurse class. And the reason is it is a friend of the nurse class here. That's why we are able to do something like this. But what I really want you to see now that that doubt is cleared is the kind of access we have to things from the base class. We will still be able to use m full name here because it was inherited as protected. So we can use it from a derived class. We can say m full name Jon Snow. This is going to work because this was inherited as protected. Now it is protected in the eyes of the nurse class. This is what we mean here. So this is okay. This is going to work. We can get the age. We can use that. And we can say John's. And we can say 23, for example. This is going to work because this is protected. But we can't use the address. If we do that, we won't be able to change it. We will get a compiler error because this is private to the base class. This is the same thing we saw in the last lecture. This is going to give us a compiler error if we try to build this program. Let's try and build it to really prove this. The build is going to be good without line 17 here, but if we uncomment it and try to build the program, let's do that. We are going to get a compiler error, and the compiler error is going to say, let's go up and see if we can get this message. It's going to say, M address is private within this context where we are trying to use it. And that's line 17 of the nurse class. If we go there, we're going to find the offending line here. So we're going to comment this out and say that this is going to give us a compiler error. Okay, so you shouldn't do this. Now that we know things from the inside, let's see how things fare on the outside. We are going to hop over to the main CPP file and include our nurse class. And we're going to create a nurse object. We can go down and say stdc out. And we're going to put in our dashes. And we're going to create a nurse object. I think we have a default constructor for a nurse. We're going to say nurse1. And we're going to basically try and do the same things we did for the player object from the outside. If we try to access the full name, now it's not going to be accessible because it was inherited with protected access level. So if we do nurse and say m full name, you're going to see that autocomplete is not here. This is a good sign that this is not accessible from this place. If we say Davy Jones, we're going to get a compiler error. And if we try to build, we're going to get a descriptive compiler error. At least I hope. So let's build. We're going to see that we build with errors. And if we go up, we're going to have our error. Nurse was not declared in this scope. Did you mean nurse 1? Yes, we meant nurse 1. Sorry for that. We're going to build again. Thank you, GCC, for pointing this out. We are going to get another kind of error. And if we look at our error here, we're going to see that M full name is inaccessible within this context because it is a protected member of the nurse class now. It was inherited as protected and we can't access it from the outside. We can access that from the inside because it is protected. But if we try to access it from the outside, we're going to get a compiler error. And this is a defining feature of protected inheritance. Even things that were public in the base class are going to become protected in the derived class. So this is the message here. And this is going to give us a compiler error. Okay, so if we also try to access nurse 1 and say M age, this is also going to give us a compiler error. Let's try to put in an age here. Let's put in 51. You're going to see that we're going to get the same kind of error. Let's really try these things out and learn about every possible way we can set up these things. If we look at the error, we're going to see that M age is protected within this context, so we can't really access it. So this is the compiler error we get. And I hope you know that if you try and access the address, you're also going to get a compiler error because that's private to the base class. So we can't even use that from a derived class like nurse here. That's not going to work. Let's say that here we have a compiler error and we're going to set up another class which is going to inherit privately and see how that works out. The class is going to be engineer. We're going to see that the error here goes away. So let's create our engineer class. We're going to put in a header file. That's going to be our engineer.h. We are also going to put in engineer.cpp. Okay, so we're going to hop over to our header file and put in our engineer class. We're going to say engineer and say that we want to inherit privately from the person class. This is the syntax here. And this is going to do private inheritance. And what this means is that anything that is public is going to become private to this class. Anything that is protected in the base class is going to become private to this class. And anything that was private in the base class is going to stay private. We want to have access to that whatsoever in the derived class directly. We are going to hop over to the CPP file and put in our implementations. We're going to have a default constructor for engineer, which is not going to be taking any parameter. We're going to have our output stream operator, which is going to still work because it is a friend of the engineer class. So all these things that were inherited to be private are going to be private to the engineer class. And any friend of the engineer class will have access to that. That's why we are able to call get full name, get age, and get address here and get these things to work. Okay, now that this is out of the way, we can try and access our things. We're going to try and do the same things we did in our nurse header. We're going to copy the code because we are trying to access the same member variables. And we're going to see how this fares in our engineer class. This is going to save us a few seconds. If we try to access the full name, this is going to work because it is private to this class. If we try to access the age, this is going to work because all these guys are now private to this class here. But if we try to access the address, this is going to give us a compiler error because address is private to the base class. If we go back to person, we're going to see that this is the case. And if you try to inherit from this class in any way, you're not going to be able to change this access level. This member variable is always going to stay private to the base class, and no derived class will be able to modify or read from this in any way. So this is the setup we have here. If we try to build, we're going to get a compiler error. Let's first take this out and show you that this is going to build just fine without this line here. And I am going to build again and show you that if we bring that in, we're going to get a compiler error. So the build is good. We can go back in our engineer class and bring in the offending line. We can uncomment this. And if we build, we're going to get a compiler error. Let's make sure you see the compiler error here. So the build was finished with errors. And if we go up, we're going to see that we have an error here. And the error is going to say M address is private within this context. And the context is what we have at line 17 in the engineer class. So we can go there and find the offending line, and we're going to comment this out, and this is going to give us a compiler error. Now you know this. But this is how things are going to work from the inside. But we also need to look at how things fare from the outside. Let's go back in our main CPP file. We are going to include our engineer class, and we are going to create an engineer object. We can go down and say stdc out and put in a bunch of dashes to separate our things. And we can create a engineer object, and that's going to be engineer1. And if we try to access the full name, that's not going to work because it is now private to the engineer class. If we say engineer1 and try to say full name and try to change the name in any way and say, for example, Olivier Godson, I am making this up. I don't know if this name exists. But the point is that this is not going to work. It is going to give you a compiler error because full name is now private to the engineer class. It was inherited to be private to the engineer class. And if you try to do this, you're going to get a compiler error. Let's try and build with GCC to really show you this. And the build is going to be finished with errors. And if we go up, we're going to find our error. Full name is inaccessible from within this context. And the offending line is at line 27 of the main CPP file. If we go there, we're going to find our line, and we're going to say that this is going to give us a compiler error. So let's say that. And we can't even access the age and the address member variables. The age is also going to be private to engineer, but the address is private to the base class. So that's not going to work either. So we can't really access that from the outside because it is now private to the engineer class. So let's go down and really show you that. We're going to go down and say engineer1 and say age. If we try to do that, that's not going to work. That's going to give us a compiler error. And if we try to build, we're going to get a compiler error along the same lines as what we just got here. The build is going to finish with errors, and if we look at our error, we're going to see that age is protected within this context, so we can't use it at line 28 of the main CPP file. This is going to give us a compiler error. Let's do that. We're going to say that here, and if we try and access the address member variable, that's not also going to work because this is even more restricted for access. It is private to the base class, so we can't access it from a derived class directly. We can't even access that from the outside, so you should really know this. So if we put in some junk data here and try to build, this is going to give us a compiler error that says that this is not accessible from the main CPP file like we are trying to do on line 29 here. So we're going to get an error, and the error is going to say address is private within this context, and the offending line is at 29 of the main CPP file. We're going to take this out, and we're going to say that this is going to give us a compiler error. This is really all I wanted you to see in this lecture, and before we wrap this up, let's try and build again and make the error go away, because I don't like to leave you with code that has compiler errors and the build is good. And this is really all I wanted you to see in this lecture. That you can do all kinds of inheritances in your C++ code. You can do public inheritance, you can do protected inheritance, you can do private inheritance. And we had a chance to look at all these scenarios in this lecture here. The message is the same as we saw in the last lecture. If you do public inheritance, anything that is public in the base class is going to stay public. In the derived class, anything that is protected is going to stay protected. Anything that is private is going to stay private. And this is really misleading in a way. The private data from the base class is not going to be private to the derived class. It's going to stay private to the base class. So if you try to use this in any way from the derived class, you're going to get compiler errors because you can't access that, even if it is part of you. Player has a person part of it, but it can't access private members from the base class. You should really know this. We have seen that we can also do protected inheritance, and that's going to constrain things to have the highest level of access to be protected. So anything that is public is going to be stripped down to protected access. Anything that is protected is going to stay protected. Anything that is private is going to be private to the base class. You should really make this super clear. We can also do private inheritance as we saw, and this is going to strip down the highest level access to be private. So anything that is public is going to be constrained to be private. Anything that is protected is going to be inherited as protected to the player class. But anything that was private in the base class is going to stay private to the base class. Even the player class won't have access to this member directly. If we really need access to private data from the base class, we might go through public getters or anything we get from the base class, but we can't access M3 directly and use it from the derived class. That's going to give us a compiler error. This is really all I wanted you to see in this lecture, and I hope you find this interesting. We are going to stop here in this lecture. In the next one, we're going to try and zoom in on private inheritance and show you some things you really need to be careful about. So go ahead and finish up here and meet me there.